Hello there. In this session, we will be exploring the area enclosed by a curve, focusing on the concept of the definite integral. The goals we aim to achieve include understanding Barrow's rule, grasping the connection between primitives and area, and using integral calculus to compute simple areas. To comprehend this lesson, you only need to be familiar with the concept of the primitive of a function. Now, what is the connection between areas and primitives? Let's consider a function of x which is positive, and we're going to define an uppercase f, as we can see on the right side. In this example, we see it is defined as the area enclosed between the graph of the function and the x-axis on the interval from -1 to x. Well, what are we exactly doing here then? Well, if I set an x on this side of the -1, I take the interval -1x, and I take the highlighted area that is left in the -1 interval x, more precisely between the x-axis and the graph of the function. That area will have a specific value or number, and that same value is what I will assign to the uppercase f. Here I represent it with the black dot that just appeared. Then above the x we have the uppercase f of x. That function, or in other words that calculation, I can perform for each value of x, and it defines, as I've already said, the uppercase f, and what we have written on the slides is simply a notation. We represent that area as the integral between -1 and x of the function of x of dx. But I cannot stress this enough. For now, that is just a notation. The actual representation would be the calculation of said area. Well, as I was saying, let's do it again for another x. I take another x, I take the area, and I assign to x its area. We are going to be doing this for all the different values of x. Within the entire domain of the function, we allow x to vary within the domain of the lowercase f, and while doing so, we define the uppercase f. All of this gives us a function, this function that we have represented here, and that function is exactly the uppercase f. Well, the fundamental theorem of calculus tells us that the function uppercase f is a primitive function lowercase f. That essentially means that, first, we have a method to calculate primitives, and second, the primitive of a function represents the swept area. Therefore, this is the main relationship between the area and the primitives. An immediate consequence of the fundamental theorem of calculus is the famous Barrow's rule. What the famous Barrow's rule tells us is that if I know this primitive that I have right here, in this case, uppercase f, then I should be able to calculate the area enclosed by any function. Let's take f as an example, and in an interval ab. For example, if we want to calculate this specific region, what should we calculate? Well, by using the uppercase f, we would take, in the first place, the function of b, which would be the whole area highlighted with red, and then we would remove the function of a between -1 and a, that area right there. These two values are simply values of the area, and as we can see, the difference between the two gives us exactly the area that we want to calculate. This is what is called Barrow's rule, the integral of a function between a and b. That would be uppercase f of b minus uppercase f of a. The calculation is quite simple. It involves taking the primitive we calculated earlier and then finding the difference using the fundamental theorem of calculus at the endpoints of the interval. In theory, this calculation we've got here is only true for the primitive uppercase f that we just calculated above. Let's take a look at the following slide. If we take a positive function, as we were doing up until now, I know that if a function does have primitive, at least one of them, which is the one I just calculated, is going to give me Barrow's rule. In other words, the area is going to be able to be calculated in that specific way, function of b minus function of a. But if g happened to be any other primitive of the lowercase f, it turns out that g is going to be f plus a constant. And well, as we see in the screen, the difference of g of b minus g of a returns to be function of b minus function of a. And what this means is that in Barrow's rule, any primitive will do. Any primitive, not only the one we have calculated, but any other primitive should work as well. Well, after all of this, we can have a proper definition. I am talking about the definition of what is called the definite integral. Given a function f and an interval from a to b, we define the definite integral of the function over the interval from a to b as simply applying Barrow's rule to one of its primitives, function of x in b and a, which is written as function of b minus function of a. It's important that f is any primitive. I no longer need to calculate it as I have done before. Secondly, there is one crucial point to emphasize. If the function is not positive, what we are calculating does not represent an area. Well, that concludes our lesson. What can we expect to achieve from this point onward? We'll now have the ability to straightforwardly calculate areas using definite integrals and apply Barrow's rule. See you in the next video. Thank you, students.